now come to every day you hear news about a new battery. I will call this, try to cover that in batteries in future. Again, reasonable amount of material has been taken from Battery University. The important thing is, which parameter will it be better? First thing that I want to point out, is there any other battery in which is expected to touch $100 per kilowatt hour? I do not see that in near future, 5-6 years. 10 years, yes, but I still look at other batteries which are promising, and maybe in 5, 6, 7 years they will start touching $100 per kilowatt hour. Because that is the current cost, and $100 will fall down further. So, need to compete with existing cells in terms of specific energies, costs, number of cycles and temperature range. Cost is a very important, probably the most important parameter. If it does not compete in costs, what will it do? Weight will matter, material, of course, all these are related. Number of cycles matter, because at the same cost, if I can get more number of cycles, its effective cost becomes less. Temperature range, this is something of immense concern. Can I get, particularly in India, can I get something which will work at 50 degrees centigrade better? Of course, these are cells. I can always make my pack work in a, even if the temperature outside is 50 degrees, I can make it work at close to 25 degrees centigrade by cooling. Lithium ion batteries that you get today, you will see its cathode will start getting more and more nickel. That is helping increase the energy density, and in anode you are adding more and more silicon. As I told you, it started with NMC 111, 433, 532, 622, 811 and now nickel rich. So, the nickel rich cathode and silica rich anode, instead of graphite use more silica. There are problems on fusing silica, it is not as easy to use, helps in improving the energy density and reducing cost. This will happen, there will still be lithium ion battery with some variation. The battery which promises quite a bit is lithium polymer. They are mostly pouch cells, and I will explain what is pouch, cylindrical and other cells. The difference between this battery and the currently used lithium ion battery, in the current lithium ion battery, electrolyte is liquid. In this, electrolyte is dry powder. It is like a, not powder, it is more like a plastic like film. It does promise and can make things better, more safer. The problem is, at room temperature it has a poor conductivity, you have to heat it to 60 degrees centigrade. So, that is not very desirable, but we should keep in India anyway the temperature is higher. If it is a 10 degrees centigrade, heating to 60 makes a huge difference, but in India you may be a little be able to use it, we keep on looking at it. There is also another thing which use gelled electrolyte instead of the liquid electrolyte or powder electrolyte, plastic film like electrolyte, gel gives you slightly higher specific energy density, makes the battery thinner. So, you will see lithium polymer coming in once in a while, you will not even know, it is still lithium ion battery. There are future batteries, lithium sulfur, lithium ion with solid electrolyte, somewhat like this, graphene graphene supercapacitors, redox flow battery, aluminum graphite battery, solid state batteries and hydrogen fuel cells, and you will keep on hearing every day about the, somebody say I have came with lithium sulfur, somebody say oh with solid electrolyte, graphene batteries, supercapacitors, redox flow, aluminum graphite, solid state batteries and hydrogen fuel cells. All of them have a, they are certainly future batteries, no doubt, but all of them have serious limitations today, and we will look at some of that. So, as I told you, these are the future batteries, and let me come to look into a little more detail. I have again put a table of all the possible future batteries and how does it really look like. The table was taking time. I am actually putting enough data for lithium air, lithium metal, solid state lithium, lithium sulfur and sodium ion. These are first set of 5 future batteries. Solid state lithium, a lot of talk is there. Now, look at it. If I could get lithium air, it is 1.3 kilowatt hour per kg. Today, we have 300 watt hour per kg. It will become 1300 watt hour per kg. Wow! This will make it almost equivalent to petrol. I would love to see that. What is the limitation? The best that somebody has shown me is 50 cycles in a lab, that also. And of course, very expensive, that is a different issue. It actually came from, there was another battery called zinc air, which used to be proposed some time back. So, it actually borrowed what is called breathing from zinc air and fuel cell concept and brought it. Good research work. If you are doing your PhD, work on this. Do you expect it to come in next 10 years? Unlikely. And compete. It's come even today, you can see it. Lithium metal battery, this is more like the current 300 watt hour per kg. I do not know how much further it can go, but the most important thing, you can charge very rapidly. 3C charge is no problem. That is the big number of life cycles are also not bad. Safety, very unsafe today. The second is, all the experiments have shown that very quickly develops what is called dendrite growth, causes electric short circuit with usage. So, yes, promising. Will it compete in cost? We do not even know. Anything close to $100, not when it comes, it may start with $1,000 and then it has to come down. But you will see lithium metal or more of lithium metal sometime. Solid state lithium, again 300 watt hour kg and possibly can go up. It also does rate it can also charge very rapidly, 3C is no problem. It is a bad when it is a cold weather. It is a very poor conductivity, it does not work at all. Cycle life in all prototypes has not exceeded 100. This has promises, I will not say that, but will it get us and compete with current lithium ion battery with silica and nickel rich in 5 years? Unlikely, but you will see more of it. A lot of excitement at times, but okay, 10 years down the line, I do see one of these two taking over. Lithium sulfur is another variation. It goes to 500 watt hour kg, so better. Today, its charging discharging rate is not good. High power you can do high power. Cycle life, the only reported cycle life is 50 cycles and that is disputed, whether it was really 50. So, could be even lower. So, yes, good work, something can happen. Lithium, sodium iron, this looks like a sodium iron or sodium ion. This is not iron, I think it is a mistake, should be sodium ion. It is very similar to lithium ion except using sodium. So, it will be cheaper. Unfortunately, watt-hour kg is not good. Still it will be cheaper, but weight will be higher. Right now the life cycles are not good, though somebody else told me you can get 500 cycles, I do not know. Low cost because it will be on par with lead acid. Whether it will be able to do depth of discharge of 85%, we do not know. So, many of these things we will not know how much depth of discharge. So, even after it comes, it has to actually go a long way before it replaces lithium ion battery. So, as I told you, the biggest interest is not 13, it is 1.3. I made a mistake, it is 1.3 kilowatt hour per kg, 1300 watt hour per kg, on par with gasoline. So, sorry about this. So, lithium, air, oh, it is 13 watt hour kg, sorry, it is 13 kilowatt hour kg. So, this is very good, yeah. So, it is right on par with gasoline. So, actually on par with gasoline in terms of energy density, but since electrical vehicles are 4 times more energy efficiency, you actually require very little of it. Actually, as I pointed out, even if I reach quarter of that, instead of 13 kilowatt hour, I can get 3 kilowatt hour, I still will be on par with gasoline. This will be fantastic, but today its cycles are very small. Lithium ion metal 300 watt hour kg, dendrite growth that induces safety hazards is a serious problem. Rapid charge is the major advantage, decent life. Solid state lithium, as I told you, anode with pure lithium and solid state solid polymer electrolyte or a ceramic separator, high energy density, poor conductivity at cool temperature, number of cycles are doubtful. Lithium sulfur better in terms of energy density, poor charging and cycle life. Sodium ion can compete in cost today. See, you cannot say because it is not 300 it is going to be as expensive, because you are replacing the expensive lithium and cobalt with sodium. So, this can improve your cost. The cycle life is still a problem. There is another called LMFP, lithium manganese iron phosphate. Somebody has come, that some of the Chinese people came. It is a much better life cycles, but watt hour per kg is again a problem. I do not think any of these things should be ruled out. We should watch, new work can be done. Every day people are doing PhDs, not 1 or 2, tens, 50s of PhDs. The other battery which are talked about quite a bit is the battery called flow battery. It is a redox battery also, redox. It is very long life, 20,000 cycles is no problem, very high capital costs. Of course, not good for EV, but for fixed application. But even for fixed high application, when the cost is very high, the interest cost itself will be higher than new battery. I can buy a new lithium ion battery every year for the interest cost itself. That is a problem and is not gone beyond a certain point. Fuel cell is another thing, talked about a lot. In last 15 days, I worked with one of the Indian R&D house, which says that we are the leaders in hydrogen. I actually worked out the cost, effective cost today. It will work out to be at least 5 times that of a lithium ion battery, usage cost. at least 5 times. That is a dilemma, even more. But can it come up in future? Very likely. You should watch this out. Supercapacitors, very high charge rate, discharge rate, but extremely expensive, extremely. That is what it is. So, people every day newspaper carry, they do not even have this basic knowledge that I talked about. If they even went to battery university, you will find enough of this. Media people should sort of say, go to the battery university, these papers, and then do it, or even this would have captured what I am talking about. So, coming to the end of this. So, if I look at it, if I look at supercapacitor, basically today it is a 5 watt-hour per kg, very expensive. Flow battery is better, 40 watt-hour kg. I talked about that, expensive is the main reason, and fuel cell is also 40 watt-hour kg, but again you will, it is extremely expensive. To sum up, lithium ion batteries with its high specific energy, low cost and decent cycle life is here to stay. The person who got Nobel Prize this year on lithium ion battery, he is a 96-year-old man. The key person working with him, I am forgetting his name, Ramakrishnan or somebody, who actually delivered on behalf of Goodrich his Nobel Prize lecture. He is an alumni of IIT Madras, and he was in one of the conferences recently in India, not recently, several months back, and he said that we keep on talking about alternate batteries, this, that and all that. I won't be very surprised if 20 years down the line you still have the lithium ion battery as the dominant battery. I think that says it all. He may be wrong, but 10 years down the line we may see something else, but it is not that it is given that you will see something else. Versions of lithium ion battery may emerge in 5 years to 7 years. Ideally, I like to see a lithium air battery. That is the real one, not solid state, not this. If I was a youngster 45 years back, and I was going to work, even though I did not have background, I would have loved to work on lithium air battery. That, I think, if it is cracked, it will make a difference. Till that time, we will have to keep on doing things. Other batteries may be more useful for stationary applications. I want to reserve my judgment because the weight there does not matter. So, but I think this is what it is.